All right, so let's it's 9:19. We'll kind of get started here. But again, we're in here, right? GeoGebra and open middle. All right. And again, I'll throw this in the chat one more time so you can see it. Everyone. All right, thank you for the comment there, Emily. All right, so that's where we are. It's just a Google Slides file with 3 things in it. All right, just to organize my thoughts. But I'm not sure if any of you have heard of open middle, right? But there is a website called openmiddle.com. I'm not going to put it in there, but I just want to show it to you quickly. I found out about open middle about a couple of years ago, and as soon as I did, I fell in love with it. Check it out. This was a site founded by Robert Kaplinski. He's on Twitter. I actively follow him, and also Nanette Johnson. And so basically here, it's like they call it challenging math problems worth solving. Like what is open middle actually? What does the open middle problem say look like? Okay, I'll give you an example of one. See, there are problems that are actually open. Now, people hear the word middle and open. What does that mean? What are you talking about? Well, for example, right? Let's talk about say algebra 1 or something like that. Solve for x. You know, that's not open middle. That's just algorithmic. You can solve for x, right? Solve an equation, right? But open middle kind of goes the other way around. Instead of asking students to solve an equation for x, why not ask them to say construct an equation that has -1.5 as a solution? See, that's a lot more challenging. And it makes students think a lot more critically and more deeply. And it's something that you can't really easily photomath your way through, if that makes sense. Again, not that I'm against photomath. I like photomath. It has a time and a place in the classroom, just not all the time. But with 21st century technology here, you know, Wolfram Alpha, photomath, even GeoGebra's CAS app, right? If we think about a lot of the questions that we ask kids, you know, like how much of that is actually like Siriable? How many of your test questions in algebra can you just ask Siri and Siri could solve it for you? You see what I mean? So that tends to be more along the like what we call lower level thinking questions. Open middle takes it and actually makes them think at a higher level. So let me just give you, I'll give you an example of one just to start. And actually in this slide right here, I'm just gonna go to the second page right here. And just to kind of like, let me see here, view slide, and view slideshow here. So right here, right, many of us as educators, we've seen this depth of knowledge wheel, right? And we think the questions we're asking students, where does it fall in this category? Is it level 1 and level 2? I know when I was in elementary and middle school, a lot of the questions my tests had were in these 2 categories. I bet you many of you could say the same, right? True or false, you know, spit back. What's the quadratic formula? Measure this length, label the diagram. Hey, let's do A through H matching, right? Again, yes, those questions have a place, but it can't be the end all in all, if you will. And then some teachers, we go like a little bit higher. Hey, can you estimate the product? Or can you interpret what this graph is telling us about this scenario? That's better, right? But now, the open middle questions, as you're going to see very quickly, tend to engage students in the higher domains here, level 3 and level 4. Level 3, you look at the words here, construct, compare and contrast. What conclusions can you draw? Ooh, differentiate, not calculus differentiate, but just differentiate, right? Critique. And then finally, even here, design, synthesize, analyze, create. See, open middle is a lot about creating. I want students in math to create. And at the same time, in this, a couple months ago, when, you know, the Omicron variant of the COVID was kind of hitting schools after Christmas break, and people are coming back and teachers are getting emails, hey, we have a bunch of new students that are quarantined now. And teachers are like pulling their hair out. What am I going to do? You know, I found that open middle is an awesome way to engage students, not only in formative assessment, but also summative. Because my philosophy is that if a student is quarantined for 5 or 6 days at home, even still, there's still students quarantined now, right? It's still going around, but less, thank God. But even if students are still quarantined now, and let's say there's a quiz on a certain day, my opinion, the students should be able to take the quiz at home and not have to make up a gazillion and one quizzes when they get back from quarantine. The fact that they're quarantined many times is not their fault. So how can we effectively engage students, formatively and summatively assess students while they're at home, right? and have it be legit and valid, because teachers are just like, beating their heads on their desk because I give them the quiz questions. They're just going to photo math and cheat it. We're going to talk about that and address it now. Okay. So open middle tends to go over in here. All right. So let me escape out of here and let's actually start really playing. And through this, we're also going to learn how to use GeoGebra Classroom too. Many teachers, the learning curve at GeoGebra, it's intuitive, but at the same time, we as teachers don't have time to, that's why we're here, a lot of us today on Saturday, right? But Tim, can you, in 5 minutes, can I just take a lesson and just use it with my kids? Something that's pre-made, cookie cut, done. I want to use it. And I say the answer to that is yes. And can I also engage my kids in higher level thinking? I say yes. So let's go ahead and do it now. Challenge accepted. So let me just see here. Okay. And we'll do this here. So now in this Google Slides here, if you go to the third slide, it's right here. It says ready to use open middle exercises. The URL is right there. There's two URLs here. The open middle site you should check out. I love that site. It's an amazing site. And as a GeoGebra lover and enthusiast, I love everything ed tech. But again, I try to let GeoGebra be a means to engage the kids. A lot of the open middle problems that you'll see are on open middle site, but I just made digital versions of them so that I could see student thought process in real time. All right. So right here, I'm going to go here to the ready to use. And if you just joined, I'll drop the direct URL link to where we're going right in the chat. So it's easier for all of you. Okay. So here is the open middle GeoGebra site here. Not site, but the page there. There it is. Okay. If you want to go there, feel free. Okay. There are over 130 items in here so far. And I plan to keep adding this over time. Many of these have been created by Steve Phelps, a GeoGebra Jedi. John Albright's got a few amazing things in here as well. But we'll take a peek at every little thing here just to see here, not everything, but we'll take a peek at some of these here. Let's just go for our elementary teachers here. Let's just look at something, something basic, say like maybe, I don't know, here, or maybe this is elementary, upper middle, but let's actually go, I don't know, here, for example, I'm going to do an open middle Pythagorean question. All right. Actually, the full resource can be found here, and it's a book, right, full of questions. And so let's take a peek at this here. Using digits between 0 to 9, no more than one time each, fill in the blanks to create a right triangle. The triangle soon to appear will be drawn on the scale, right? So I can actually try, and actually I'm going to go here to this open middle book, right? And I'm, as a teacher, this is ready to use. I'm going to hit create lesson at the top. You're going to get a little tutorial on GeoGebra Classroom here. If this is your first day, all right, I can't answer the door. I'm speaking now. Got 4 kids at home, but right here. So right here, if we hit create lesson right there, right? I don't figure they're knocking. Sorry. I'm just going to create it. And then I don't care what LMS you use, Google Classroom, Schoology, Moodle, Canvas. All I need to do is copy that URL there and throw it in the LMS my students use. So since many of you have GeoGebra accounts, whoops, I'm going to throw it in the chat here. All right. So come and join here. Where'd the chat go? There it is. All right. Come join. All right. So I'll put it again there. Please join. There we go. Hello, Sarah, Catherine. All right. There we go. See here, this is what I see as a teacher. And so all I want you guys to start doing is, could you start typing numbers in those elements there? Okay. See here. I could see Samantha. Hello, hey Samantha. I can see Samantha here started putting 7 and 8 for the legs of that triangle right there. But I just simply want you to, using digits 0 to 9, no more than once, I want you to fill in. I want you to create a right triangle for me. You see how this is? It's like, sure, I can give kids Pythagorean theorem questions, solve for the hypotenuse, solve for the legs, solve for this, solve for that. Great. But see, it's just a simple twist. Can I just ask students to create a right triangle? And look at this right here. We're all just playing around here, right? But 6, 5, 30. You tried to create a hypotenuse that's shorter than or equal to a leg. So now I can have, again, not picking on you. I'm just trying to show right here, right? In fact, I can anonymize the names if that makes people feel better, right? You can show names or high names. But I could see here, right? See student 9. Okay, created a right triangle there, right? So did student 10's working on it, student 11. But see here, I'm engaging students in constructive thinking and learning here. Say we just discovered the Pythagorean theorem, and now I'm asking them to simply build a right triangle, just with the added constraint that there's no repeated digits. That's all. Okay. Again, a warm up there. All right, and students know. And then as a teacher, I ask them to algebraically justify after the fact. I want kids to create first, justify after. And if you like what you see in this activity, you can go to this activity. It's in the open middle book. You can hit create lesson, give your kids the link to join it, and you can watch their thoughts in real time. And you could create a lesson in like literally 10 seconds or less, right? This is ready to use, and you don't have to do the GeoGebra brains behind it. This has been done already. It's there for the taking. Use it if you want to engage your kids in a task like this. Okay. I want to make sure I check the chat every so often there. How is question 1, 2, or 3 different from each other? That is a great question, Jared. I should probably look at that. So if you as a teacher want to see this, right, I could actually go to lesson overview page and actually write question 1, right? Try to show it's the right triangle in Q2. All right. And so right here, right, I think I have I think it's the same question, but I forgot to put in the directions to make it different from the one you made before. So I'm simply asking students to make 4 different right triangles. That's all, right? And obviously they don't need to be Pythagorean triples either, right? As obviously I could put like a 5 and a 6, right? And this is going to be a 61, right here. But oh shoot, I have repeated digits. So okay, now I have the number sense here, right? 5 squared is a 25, that's 36. 5 and 6, that's and then a 1, right? So again, a little bit of number sense going on here, but what if I did 7 and 6? And I'm thinking I could use the pen tool. Oh, it's 49 and 36, right? 36, that's 15, 1, 5, 8. So that 85. So I should do my math right. Hey, you know what I mean? And no repeated digits there. So if they could just, as a warm-up, just to create 4 different right triangles, and then we move on. You see what I'm saying? This is constructive thinking. How many triangles are possible? I haven't figured it out, but I know there's people that can run algorithms to do that. I know sometimes on Twitter, I'll ask Chris B or Steve Phelps to kind of just run an algorithm quickly. I forgot what program, but they can run out all the possibilities, whatever. You could probably make a Google sheet, put all the possible legs in one column, the legs in the other column, and then do like A1 squared plus B1 squared and see, you know what I'm saying? So a table like that, in my opinion, is easy to generate. But to me, I don't really care how many solutions there are. And I'm not saying it's not important, but I just want to see what kids could create. All right. So yeah, anytime. So again, I want to just show you some other things that are possible here with open middle. And again, a lot of these problems, some of these problems I created from scratch on my own, but many of the problems I stole from here. All right. And I can't remember where it was, but like say like right here, for example, I don't know if this applies here, using digits 0 to 9. At most 1 time each, fill in the boxes to make an equivalent ratio with a unit rate that has the greatest possible value. Oh, look at that problem right there. Now, I haven't built it in GeoGebra, but just look at the nature of this question, right? See how this is DOK3 automatically? It's not a regurgitate. It's not a true, false, or recall, right? It's not low-level thinking. Students have to critically think about this and go in there. See, with open middle, this is the logic, all right? The beginning part of the problem is closed. The end part of the problem is closed. There is definitely a closed beginning. Understand the problem. What am I being asked to do, right? And there is a closed end. There is a solution here. But what part is open? It's the middle. I love the middle part of an open middle problem because I've given all my classes problems like these, and oh my gosh, teachers, the thought processes, the active engagement in here, and the discourse that goes on among students, it's through the ceiling. I love it. And honestly, if I was teaching a 5th grade class where we're doing like this, and I have some kids at home, some kids in class, I would have the kids. I did this in my high school class with trig graphs. I'll show you an example, but I had students at home in GeoGebra classroom, and I had kids in the class in GeoGebra classroom. They were FaceTiming each other or joining the Google Meet, and they were brainstorming, sharing screens over an open middle problem. And I counted that as a small quiz grade. You see what I'm saying? So again, you can't photo math these things. Not that photo math is bad, but these are questions that engage kids in higher level thinking. And my sense is that this is an alternate form of assessment. And in my opinion, it's more powerful because, the whole like typical 1960s, put everything away, and spit back what you know. Yeah, that has a place in the classroom today, but with 21st century technology here, combining this with GeoGebra, I find is a huge game changer for me and my students. And I believe it can be for you as well. Let's take a look at some more. Right here, I'll show you what I mean. I'm going to go ahead and take a look at something over here. Let me just go to, and again, there's over 100 things here, but let me steal, I'll take another simple one here. Where'd it go? It's percentages here. Let me see, is it here? Nope, give me a sec. Here it is. Here's a popular open middle problem from Adrian Burns, right? And if you want to play with this, I'll make a lesson out of it too. So you can create this here. See, teachers 1, 2, 3. It's already made. Hit create lesson. Copy that URL. You paste it in your LMS. Easy, in 10 seconds, you're done. All right. I'm going to give it to you now so you could play. Join here. Here we go. All right. And again, I strongly recommend you, I would strongly encourage you to squish the Zoom window to one side and have your Chrome window on the other, because you want to be able to see my presentation and be able to play at the same time, if that makes sense. All right. Now, these number templates were created by Steve Phelps, the 0 through 9 white squares. Steve made the polygon boxes and the numbers there. So I took a look at his construction, just as Lebo was saying before. You can see how other people made things. I actually copied his activity and I deleted all the stuff of his I didn't want, but I kept the number squares, and I built this in GeoGebra so that I can engage my kids in higher level thinking here. So for example, like say right here, I'm going to actually join as this one. No, I won't join as a student here. But if you take a look at this problem here, right, there's 4 tasks, right? See how here I have a double number line when it comes to percentages, right? I want to see if students can construct an accurate number line here. So obviously the easiest percentage students I think can think of is 50. Most students know that means half, right? But now I want you to make a double number line statement that's true, with the added stipulation that you cannot repeat the digit. So students will come here and put in, like, say, obviously, if I put a 34 here, right, this would have to be a 68, right? And look at this. See, what if I did a 61? You see how GeoGebra, the power of GeoGebra now, see how it tells you, hey, 34 is a little bit, 34 is a little bit more than 50%, isn't it? Because if 61 is the whole, right? I want you to see if you can, you know what I mean, kind of do it that way. Okay, so is it 62? I believe it or not, I've had students in high school guessing and checking on something like this, which is kind of scary. But at the same time, we could take the first 10 minutes of class to really talk about, you know, what this conceptually, what this means, right? So I did this for credit recovery in middle school last year. That's when I built this activity, because one of the units in the IM curriculum was percentages. And so I had kids at home. I had kids here. I'm not going to give them a paper quiz, 34% to 53, 86%. No, because they can ask Siri those things. And what learning is truly taking place in that case? 0. Right. But I give them a quiz, or I give them a warm up that looks like this now. 50 minutes later, their brains were hurting. And now I could talk to kids like, what does it mean? What does a percentage actually mean? Let's really talk and think about this here, you know? And so now, so I've had students use, like, you know, 50%. I ask them, what are some other popular percentages you have? And they'll think, oh, 25 is a popular percent, right? Oh, that means a quarter. So can you tell me what a quarter of 68 is? Can I use my calculator? Sure, why not? Whatever, isn't it 17? You see what I mean? See, there's tons of possibilities here. And I want students to justify why. We still have that, either a verbal discussion or put on paper, whatever, that's fine. But they need to be able to set this up, if that makes sense. And as Lebo pointed out earlier, all right, let me see here. Okay, yeah, I will definitely do that, Victoria. I apologize for there. Right here, let's see. Yeah, I'm just trying to check the chat there as I'm going through. But right here, so now most students could do the 25% and 50%. Again, there's 3 setups here, because I ask them to simply find another one that's different from the one above. Okay, so then now here's what I do the next day to differentiate a little bit, or maybe to just give them more of a challenge. Remember what Lebo said? I go here, I hit, actually I have to look at the original activity. So I'm actually going to go to view original, or I'm going to find it in the open middle book there. This is the original problem. So to answer your question, Victoria, all right, here's how you assign a GeoGebra activity as a lesson. Okay, you find an activity that you fall in love with, say it's this one. Okay, what you want to do is go up here to the box in the upper right corner and press create lesson. Okay, once you press create lesson, okay, I'll do it now. All right, this is what I'm doing here. So I can change the title of it, warm up, say 219 FLGGB, right? And I'll hit create. So Victoria, this is the teacher view of the lesson where I can see all students' work in real time. But to have my students join, just simply copy this right here. And you want to take that link you get, you copy it, and that's what you paste in Schoology or your Google Classroom or whatever your learning management system is, if that makes sense. Okay. Oh, I want to show you one more thing here too. If you click on, oops, actually, hang on a second. Where is it? If you click on, I want to show you some other thing. If you click on that link here to share it, check this out. You can actually add a co-teacher. Desmos has this feature. It's really nice, but if you team teach with a special education teacher, as long as they have a GeoGebra account, you could type in their GeoGebra username or their email that they use to create the GeoGebra account, and you can actually add that person to have a teacher view of the GeoGebra lesson. Because anybody else that gets that link right now, if I drop that link to you, you're gonna get a student view. But if you want to see what I see, and you're like at home and I'm here, or whatever, then you'll be able to see that. Okay, so that's how you add a co-teacher. It's so easy to add a co-teacher. Again, to add a co-teacher, to view what you view, go here. Click on that button and type in the user's name right here. So I'm going to add, I can add in my, you know what I mean? I have another Gmail, but I'm not going to do it right now. But so I could prove it to you, but just take my word for it. You can do it. All right. So that's how you do it. So does that help? Yeah, I agree, Maria. It's 100%. It's a game changer. It is a game changer. So that's how you do it, Victoria. That's a great question. I apologize if I went too fast right there. That will not match the bottom. It should. So in this one, Susan, if you leave a box blank, it takes it as a 0. That's kind of when Steve Phelps programmed this, it made it blank. But I tell students, if I see a blank there, GeoGebra interprets it as a 0, but it's actually, in reality, it's not. But I tell students, I want to see all thumbnails. I want to see all the boxes filled in. So like right here, let me just go back to where the class was. Where was it? Hang on a second. It's on my profile. There it is. This is where everybody is here. See? And look at this. I could see it's almost like I'm security at a casino, right? I could see what everybody's doing in real time. It's pretty awesome. You know, and again, here, so student 19, I could have a discussion. It's like, well, what's greater? When it comes to, is 25% of 38 greater or is 14 greater? You see what I mean? Talking about double number with the double number line there. So what I would often do for students who need more of a challenge now, if that makes sense, is I would actually take that original lesson. And as Lebo said, you know what? I want to use this again, but I want to add one more condition. So I'm going to go up here. Again, if you find a GeoGebra activity you like, but you want to change something about it, you don't want to change the program in GeoGebra. I don't have time for that. But you want to change the directions a little bit, or you don't like the wording of something. You want to make it a million times better. You should. All right. So go up here to the 3 dots. And just like you do, what do you do to a Google Doc that you can't edit? You make a copy, right? It's the same in GeoGebra. So I go here and hit copy activity. And look at this. Just as Lebo showed us, copy of. So I'm going to call this part 2, right? And you know what I'm going to say here in the directions? Okay, drag in the digits in the boxes. And here's the other rule, okay? I want you to use percentages other than 50%, 25%, and 75%. Because aren't those the ones that students are going to want to go to, right? But I want to challenge them more now. I say, I want you to create a true double number line statement now without repeating digits. But in this case, I want you to make them, I want to stretch it a little bit. And that actually makes students like, oh, that's actually a lot harder for kids. It really is. Because then they have to think outside the box. Well, what could I possibly done, right? So see here, it's the same applet, but now I made some different directions. Okay. So again, what I'm thinking about is, here's an example, 20%. Call that a 65. Well, 20% is a fifth, right? So that here's an example. That's 13. You see what I mean? But again, this is actually a lot harder for students, even in the upper grades. Try it. You'd be surprised. But again, talk about conceptual view percentages here. I think it's powerful. All right. See how kids are creating. This is DOK3. DOK3. Now, a DOK4. How do I make this a DOK4? Again, I'm not going to type it in, but here's my interpretation of how you could. Using digits 0 to 9, no more than one time each, make a true number line statement. But now here's the part that makes it from DOK3 to DOK4. What is the highest possible percentage you can create at the bottom? And here's another DOK4 question. What is the lowest possible percentage you can create given this restriction of not being able to repeat digits? You see how much more of a challenge that is now for kids? And you see now how I can formatively assess their work, whether they're in Ishabru, Mongolia, halfway around the world, or whether they're right here in my classroom, 6 feet away from me. It doesn't matter where they are. I can see their thought process all in real time. And if you want to use Google or Siri, like I said, please feel free. You can Google this all you want. You're probably not going to find anything. Not that I'm out to get you, but obviously use the calculator to divide, get the percentage. Of course, you'd want to use the iPhone calculator. I don't care. You see what I'm saying? But that's the key thing here. All right. And to be honest with you, I honestly don't know what the answer to that DOK4 question is. I'd have to play around with it and figure it out myself. So I ask kids to find out stuff like this, and I don't even know the solution to it. And I think I get an optimal solution, and then my students prove me wrong, and they find something that's higher than what I thought. I learn from them. It's great. It's great. As teachers, we don't have to have all the answers. We don't. But we just need to have that growth mindset. And I know every one of you here have the growth mindset, because you wouldn't be taking a Saturday morning or night being here if you didn't. All right. Let's have some more fun with Open Middle. I want to show you what else is possible here. I know I got 10 minutes to go before Q&A, but we are just starting to scratch the surface with Open Middle here. And you got your GeoGebra classroom tutorial in there. Look at this side. I love this. This is amazing. Let's have some more fun with let's do some algebra stuff here. Let me go back to, again, if you lose it, just Google Open Middle and GeoGebra. And so if you check Open Middle and you want the book, you have the link, but where it says any resource type, I like to find books right here. If you're looking for volumes of stuff, that's books. Activities or single activities. But I know I have an Open Middle book, and that's this one right here with the big fat GeoGebra symbol on it. And that's where we started before. All right. So let's actually take a look here. I'm not going to make any more classes. I just want to give you some examples here. All right. Even geometry, we talk about complementary and supplementary angles, right? Well, why not take a DOK2 question, make a DOK3? Look at this question. Using digits 0 to 9 at most once each, fill in the boxes to make the statement true. See the simplicity of it? It's got a closed beginning, it has a closed end. The middle part is open. You could have kids play around with this. And so, sure, could I do this on paper? Absolutely, I could. There's no need for GeoGebra. But for the kids who are remote, I'm thinking, you know what? Why not? What the heck? Why not actually have them play with it? I don't know. I can move this over here, just try to see it. But I got to make these complementary. So it's 87 and 03, right? Let me try that. Okay, so that looks complementary. Oh, repeated digits exist. Why I have thing repeating here? You see what I mean? But you see how something like this, you see how the fact that now what are my students focusing on? They're not focused on the definitions of comp and sup. It's almost like those definitions become secondary. And what are they more worried about? They're more worried about the fact that they have to have the number sense here. You see how common sense is I can't make this a 5? Because if I make this one's digit a 5, that's got to be a 5. We can go back and have them talk in place value in this geometry class. There's middle school like activity, if that makes sense, right? But there are lots of solutions here. They just have to find one, right? But you see, if students can engage in high level thinking in something like this, then the definitions of complementary, supplementary on their next test where they put everything away, I'm not worried about that because most of them are going to get it. Find the supplement of a 34-degree angle. That's a freaking joke if they could do something like this. You see what I'm saying? This is a DOK2/3 problem. You want to make a DOK4? What is the highest possible obtuse angle I can make under these conditions? Copy the activity, paste what I just said in the directions, save it, make a lesson out of it. Now you have a warm up for tomorrow. Done in 1, 2, 3. Okay. Something else I want to show you here. Let me just go back and look at the chat there. I know I got, yeah, these restos already made. Okay. Yeah, and let me see. Samantha Cruz here. Let's check it out. Yeah, Pythagorean Equality right there, right? I'm going to add this to the book there, right? This is Sam Cruz's there. Let's just play with it. All right, 54, 23, 16. Let's see. Oh, snap. Right. So again, a lot of this, that's awesome, Sam. Thanks. I'll definitely put it in there if it's not there. But a lot of the things here are already made. They're in this book. And anytime I see some middle stuff like Sam's, I'm going to throw it in there. All right. So there's a lot here. There's a lot of 3D stuff too. I'll just show you a couple examples. I'll stop talking at 55 to answer more questions. I got 5 minutes here. But where'd it go? Where'd it go? Where'd it go? Let me go copy that URL again. And there we go. We're right here. It's that second link there, open middle. Again, even from surface area and volume right here. Like I actually had one. I wish I could show you all these, but I can't. But right here, like, check this one out here. This is one of my favorites here. This is an open middle problem. It's on their site from Dr. Brian Lack. This prism is made up of 27 identical cubes. You can drag the white points here. See what I'm saying? Away from it to take cubes on or off. But what is the greatest possible surface area you can make by removing one or more cubes here? That's like DLK4 right there automatically. See how the finding surface area is secondary now, right? And I go here, move it up. My computer's a little slow, I'm sorry. But see here, I can create a GeoGebra lesson out of something like this and actually have kids engage here. And the virtual manipulative is here. All right. It's really, really powerful there. You can move this out and work on it that way. So other things too, just to show you some algebra stuff here. How about the distributive property? Instead of asking kids to simplify an expression, why not actually have them build one? Right. Let's see. And again, for some algebra students, it's a lot harder than it looks. All right. That's got to be 1, 2. Oh, snap. I can't do that because the 2 is being used. You see what I'm saying? So let's go back to the drawing board here. What if I did a 5, right? Oh, that's got to be 20, right? 20 there. Again, these number templates were made by Steve Phelps. I just copied it and just made it kind of like something like this. But oh, see, you see how it's like, it's still a challenge there? And then I like to have number sense talk with students. What number is it? What number is it not smart to put here? Like I would think, oh, probably a 1 or a 0. You see what I'm saying? But again, instead of asking kids to simplify expressions, a lot of times in credit recovery last year, when half were home, half were here, I asked them to build expressions every day and I assessed them that way. All right. Again, look through that open middle book. There's tons of stuff there, even from something like trigonometry. For example, say something like this. All right. This one I gave this to my pre-calc class on paper first, and then halfway through the period, I had them work on it. There. So see, the goal is to using digits 0 to 9. You can't repeat a digit. That's the rule. I want you to create a setup. So let me try 4, 3. Let's see, 4. Obviously, they have to remember that the period, obviously, if I make this 2 pi over 4, right, the 4 becomes the period, right? 6. All right, let's see. I got it right there. So what's the min? The min looks like it's 2, right? Ooh, snap. You know what I mean? So now I'm thinking, well, the period is 2, but wait a minute, I have a 2 here. So, oh, I could also 2/4, I could write as 1/2, right? But, oh, wait, it's still, this got my pre-calc students thinking. And for my students who are home, they paired up with someone who was in class. After painfully working through this a little bit there, that counted as a quiz grade. You see what I mean? So open middle is a great way. You can even go up through calculus here. How about something like this? I think using digits 1 to 9 at most 1 time each, fill in place a digit in each box to make a solution that's as close to 100 as you possibly can. Right? Sure, the fundamental theorem of calculus, cap, F, B, medicated. Yeah, they got to know that, but that becomes secondary. Right? Here, it's like, wow, we're looking at areas and how fast the power function changes. A lot of great stuff here, a lot of powerful stuff. So let's see, what else do we have here? Yeah, so let's see, we got that. Yeah, like I said, the open middle book, I'll throw the link in the chat again for those who are there. Again, open middle is great. Check out open middle's website too. All right. Open middle resource. Create lessons from any of these. You can start as early as Monday. Just find something you love, hit create lesson, get the link, have your students join, and you can engage your students in higher level thinking very fast and watch their thinking live in real time, regardless of whether they're at class or at home. And I actually walk around my Chromebook as I'm walking around the class. Most of my kids are back in classroom, thank God. You know, there's very few that are home. In fact, I think this week I had a record with no one out. It was great. You know, yeah. Can you combine multiple activities in a single lesson? Paul, yes, you can. That's what would be called creating a GeoGebra book. And so I have a YouTube video of how to do that. So I will actually post it. If you stick around when people leave, I'll find it on YouTube and I'll post it here for you. Okay. A book is a volume. So I can create an activity from a book just to show you here. Let me show what I mean here. See this right here. Let me just show you something here. Monique, I think, is going to highlight the illustrative math curriculum and GeoGebra site. Monique's out later on today. This is GeoGebra's IM curriculum. I'll show you a quick example here since you asked. You're welcome, Paul. So right here, I'm going to look at something from grade 6, say area and surface area. Again, Monique's going to do a much slower version of this than I am. But where I go to student materials. So Paul, you see how this is a book right here? This book has 2 chapters. It has a lesson and it has a practice. All right. So if I find a GeoGebra book, which is a volume of activities, if I press create lesson right here, all right, I'm actually going to create a lesson for the whole book, everything in that book. But if I go back to where I was, if I click on the lesson icon, you see how it's just the lesson component. If I press create lesson from here, GeoGebra gives me the option. It says, hey, Tim, you sure you want to do only the activity? We think you want only the activity, the small part of the book by default, right? But if you want to do the whole book, you could check that instead, and it'll give you everything in the book so that when you press the create lesson button as a teacher, that'll have all the activities in that book for the 2 activities. Kids will see both activities. If you click this one here, kids don't only get a GeoGebra lesson for only that component of the book, if that makes sense. Okay. But yeah, I think, Kasha, if you want to hop back on, I think, I know I'm just about out of time here. So, yeah.
Wonderful. Thank you so much, Tim. Oh my God, so much energy always. All these creators, all these, innovative people. We love you, Tim. As you know, you share with us so generously. Thank you so much.
Thank you. And I learned so much of the community. I love Steve Phelps's work, Anthony Orr's work, Vincent's. It's just, I learned, it's like Isaac Newton. If I've seen farther than Isaac Newton said, if I've seen farther than everybody else, which I haven't, but if I've seen a lot farther, it's because I've stood on the shoulders of giants. And Newton was that's me, and that's the GeoGebra community for me right there. That's my heart.
Beautifully said that we stand on your shoulders as well. Big shoulders with, how many kids do you have?
4.
Oh my God.
That's why people knocking at the door.
Planning more? Who knows?
No.
Oh, no. Okay, Tim, thank you so much. I hope to see you in person with all your family next year for Florida. We already planned next year. We hope it will be mixed so people from all the world can join via internet, but a lot of people are going to be in person. That will be so on. Thank you so much. I have information. There's still some people who cannot go, a lot of people who cannot go in the Zoom events. Looks that this is more complicated than we thought. I heard somebody there is some hack you can do to get to our event.
I don't know, but I know that you guys are going to put it on YouTube at some point next week,
that
right?
Would be wonderful. Yeah. Thank you, Tim, for reminding that. Yes, we will put it in YouTube. So all this will be, but if anybody has a hack, please contact me. So I will share with the world through the Facebook. I'm old typer. I am not using Twitter. Maybe Samantha can put it. Thank you so much, Tim. And let's join other people, other wonderful speakers. Thank you, Tim. And let's leave the room, finish the webinar, and let's go finish the recording. Let's go to the lobby and then to the other room. This is one of the ways. Thank you. You see, there's so many people saying.
You're welcome, everybody. Thank you so much for the kind words. All right.
We are so happy we had you here. Wonderful. Thank you. Bye.
You got it. Bye.